In the last class, we learnt about the boat conformation. It means it has a no angular strain. It means angle strain is absent but torsional strain is present, and also has a flag pole interaction between the hydrogen atom. It means the carbon atom of first and fourth, there will be interaction, that is called it as a flag pole interaction. Next is twisted boat conformation. Here it is more stable than the boat conformation, but it is less stable than the chair conformation. Here torsional strain and the flag pole interaction will be reduced in the twisted boat form. So the order is chair is more stable than twisted boat. Twisted boat is more stable than boat. Boat is more stable than off chair. Okay, this is all about the conformation of the cyclohexane boat conformation. Okay, next, conformation of monosubstituted cyclohexane. Monosubstituted means only one substituent group is attached to the cyclohexane. Okay, here the substituent group can occupy either in the axial or equatorial position. In axial position it is less stable. This is more stable because in axial position the hydrogen atoms, here the presence of hydrogen atoms in the methyl group should be near to axial position of hydrogen atom. Therefore steric hindrance will be taking place. But in the equatorial there is no axial hydrogen atom, so that's why it has a less steric hindrance, so it is more stable compared to axial position. Okay, next, conformation of disubstituted cyclohexane. With respect to disubstituted, cyclohexane has three isomers. First one is 1,2 dimethyl cyclohexane. It means you have to give the number 1 2 3 4 5 6 para, ortho, meta position. Okay, this is para position, this is ortho, this is meta position. Then here 1, 3, third, the methyl group is substituted at third position, and here fourth position. Okay, this is all about the last class. In today's class we learnt about the, depending on the orientation, continuation of conformation of disubstituted cyclohexane. In that, depending on the orientation of the 2-methyl group, we can determine their conformation. In that, it means orientation means substitution of methyl group in the different position. Here substitution will be taking place. There will be three isomers are possible: 1 2, 1 3, 1 4. Okay, next, substitution. Here there will be one column is there, substitution and orientation. Orientation means either in the axial position or in the equatorial position. Orientation of methyl group, CH3 group. Next, conformation. In substitution, 1, 2, it means first one 1, 2 dimethyl cyclohexane and 1, 4. Okay, both have the same orientation should be taking place, and conformation also. Here orientation of methyl groups, 2 methyl groups are occupied at AA position. A means axial, E means equatorial. Here two possibilities are there. Orientation of methyl group, there will be two possibilities are present in that, AA or EE. Okay, it means these two methyl groups should be substituted at axial position or at the equatorial position. When methyl group is substituted at axial position or equatorial position, the conformation is trans isomer. Okay, the conformation is trans isomer. If in case the methyl group is substituted at axial and equatorial, or equatorial and axial, these are same. Okay, ಇಲ್ಲೇನಾಗುತ್ತೆ ಮಿಥೈಲ್ ಗ್ರೂಪು ಎರಡು ಆಕ್ಸಿಯಲ್ ಪೊಸಿಷನ್ಗೆ ಆದರೆ ಅಥವಾ ಎರಡು ಈಕ್ವಟೋರಿಯಲ್ ಪೊಸಿಷನ್ಗೆ ಆದರೆ ಅದು ಟ್ರಾನ್ಸ್ ಐಸೋಮರ್ ಆಗಿರುತ್ತೆ. ಅದೇ ಥರ ಇಲ್ಲಿ ಅಥವಾ ಇನ್ನೊಂದು ಪಾಸಿಬಿಲಿಟೀಸ್ ಏನಪ್ಪ ಅಂತಂದರೆ ಒಂದು ಆಕ್ಸಿಯಲ್ಲು ಒಂದು ಈಕ್ವಟೋರಿಯಲ್ ಪೊಸಿಷನ್ಗಾದರೆ ಅದು ಸಿಸ್ ಐಸೋಮರ್ ಆಗಿರುತ್ತೆ. ಗೊತ್ತಾಯ್ತಾ? ಟ್ರಾನ್ಸ್ ಐಸೋಮರ್ ಮತ್ತು ಸಿಸ್ ಐಸೋಮರ್ ಅಂತಂದರೆ ಗೊತ್ತಿದೆ. ಇಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ಸ್ ಅಥವಾ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ಸ್ ಇಲ್ಲ. ಸೊ ಹಾಗಾಗಿ ಸೇಮ್ ಗ್ರೂಪ್ ಇದೆ. ಸೊ ಈ ರೀತಿ ಇದ್ದಾಗ ಸೈಕ್ಲೋಹೆಕ್ಸೇನಲ್ಲಿ 2 ಆಕ್ಸಿಯಲ್ ಪೊಸಿಷನ್ಗೆ ಆದರೆ ಟ್ರಾನ್ಸ್ ಆಗಿರುತ್ತೆ, ಡಿಫ್ರೆಂಟಾಗಾದರೆ ಸಿಸ್ ಆಗಿರುತ್ತೆ. ದೆನ್ ಸೆಕೆಂಡ್ ಒನ್ ಈಸ್ 1,3 substitution. Here A or EE. Okay, in the 1,3 substitution, the 2 methyl group is substituted at both the axial position or in the equatorial position. That isomer is cis isomer. You have to know about that in the positions. Okay, not only for methyl group, for other group also there will be 1,2 and 1,4 position. AA or EE means trans isomer, AE or EA means cis isomer. Okay, but in the 1,3 position, here 1,3 position, there will be AA or EE. It means 2 methyl group is substituted at 2 axial position or at a equatorial position, that is cis isomer, or EA or AE, that is trans isomer. This will be the vice versa of positions 1,2 and 1,4. When at axial position it is trans, but in 1,3 axial position is it cis. Okay, next we will know about the 1 by 1 conformation. Okay, trans 1,2, cis 1,2, and trans 1,4 and cis 1,4 and 1,3 also. Then in that first one is trans 1,2 dimethyl cyclohexane. Cyclohexane, it means AA or EE. Okay, A means axial, E means equatorial. Okay, next here the structure of cyclohexane is at play. This is the one and this is the one. Okay, if it is in the, you have to write in the chair form. This is okay. Here you have to take it. This will be the 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. Okay, there will be different numbering for different conformation. You can take it. Here for 1,2 dimethyl cyclohexane, this is 1, 2, 3, 4, 5, 6. Okay, and in that there will be axial position. The methyl group should be substituted at axial position. Here 1,2 is there. 1,2, 1, 2, 3, 4, 5, 6. Okay, 1, 2. Here also 1, 2. This is axial. Then in the equatorial position, okay, equatorial position, that should be like this. Okay, axial, that should be upper side or a downer side. Equatorial, slightly up or slightly down. Okay, this is equatorial, this is EE. This is the structure of cyclohexane. 1,2 dimethyl cyclohexane. Here I am not giving a numbering. This is same for equatorial also. Okay, in the above structure, EE 1,2 dimethyl 1,2 dimethyl cyclohexane is more stable than AA. Okay, because in axial position there will be 1,3 diaxial interaction will be taking place. Okay, in this axial position 1 and 3, okay, 1 and 3, they have a diaxial interaction, because here it has a one axial position is here, so then other two is comes here. Okay, this will be the interaction with the first carbon atom, so it is less stable. Okay, ಬಿಕಾಸ್ ಇಲ್ಲಿ ಮೀಥೈಲ್ ಗ್ರೂಪ್ ಇರುತ್ತೆ ಕಣ್ರಪ್ಪ, ಲಾಸ್ಟ್ ಹೇಳ್ಕೊಟ್ನಲ್ಲ ಮೀಥೈಲ್ ಗ್ರೂಪ್ ಇರುತ್ತೆ. ಮೀಥೈಲ್ ಗ್ರೂಪಲ್ಲಿದ್ದಾಗ ಇಲ್ಲಿ CH3 HH ಇರುತ್ತೆ. ಈ 2 H ಈ ಥರ್ಡ್ ಕಾರ್ಬನ್ ಆಟಮಲ್ಲಿರುವಂಥ ಹೈಡ್ರೋಜನ್ ಜೊತೆ ಇಂಟರಾಕ್ಟ್ ಮಾಡಿದಾಗ ಇಟ್ ಈಸ್ ಲೆಸ್ ಸ್ಟೇಬಲ್. ಓಕೆ, ಸೊ EE ಈಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್. ಓಕೆ, ಗೊತ್ತಾಯ್ತಲ್ವ ಏನಕ್ಕೆ ಅಂತ. EE ಈಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್ ದ್ಯಾನ್ AA ಬಿಕಾಸ್ ಇನ್ ದ ಆಕ್ಸಿಯಲ್ ಪೊಸಿಷನ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸಸ್ ದ 1,3 ಡೈಆಕ್ಸಿಯಲ್ ಇಂಟರಾಕ್ಷನ್. This is all about the trans 1,2 dimethyl cyclohexane. Next, second one is cis 1,2 dimethyl cyclohexane, that is AE or EA. Here this is the cyclohexane 1,2 dimethyl cyclohexane, and also the structure of cyclohexane is here. I am giving the numbering is same for cis and trans isomer of 1,2 dimethyl cyclohexane. ಎರಡಕ್ಕೂ ನಂಬರಿಂಗ್ ಒಂದೇ ಇರುತ್ತೆ, ನಾನು ನಂಬರಿಂಗ್ ಕೊಡ್ತಿಲ್ಲ. ಓಕೆ, ಹಿಯರ್ one is in equatorial position and other is in axial position. Okay, this is the A, E or EA. Okay, whatever it may be. Then next, second one is, this is A position, this is E position, this is EA or AE, whatever it may be. Okay, this is the cis isomer of 1,2 dimethyl cyclohexane AE or EA. Okay, in that AE or EA equally stable. Okay, because there will be no different substituent groups here. In the A position and E position both are CH3 group is present, so that's why it is equally stable. ಇದರಲ್ಲಿ ಯಾವುದೇ ಜಾಸ್ತಿ ಸ್ಟೇಬಲ್ ಯಾವುದು ಕಡಿಮೆ ಸ್ಟೇಬಲ್ ಅಂತ ಇರಲ್ಲ. ಯಾಕೆ ಅಂತಂದರೆ ಎರಡು ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪು CH3 ಗ್ರೂಪ್ ಆಗಿರೋದ್ರಿಂದ, ಅಂದರೆ ಈಕ್ವಲ್ ಸೇಮ್ ಗ್ರೂಪ್ ಆಗಿರೋದ್ರಿಂದ ಇದಕ್ಕೆ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ. ಬಟ್ ಇಲ್ಲಿ ಮಾತ್ರ ಡಿಫ್ರೆಂಟ್ ಬರುತ್ತೆ. ಓಕೆ, ಇಫ್ ಇನ್ ಕೇಸ್ ಇನ್ ದ ಪ್ಲೇಸ್ ಆಫ್ ಸೇಮ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ ವಿ ಕ್ಯಾನ್ ಯೂಸ್ ಎ different substituent group also. If the two substituent groups attached to different, then which one is more stable is in the substituent group. For example, CH3 and NO2 is more, don't take it as NO2, C2H5. Okay, C2H5 is more bulky than CH3. Okay, it has a more mass, size ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ದಿಸ್ C2H5 ಶುಡ್ ಬಿ ಅಟ್ಯಾಚ್ಡ್ ಅಟ್ ಈಕ್ವಟೋರಿಯಲ್ ಪೊಸಿಷನ್. ಅಂತಂದರೆ ನಿಮಗೆ ಕೊಟ್ಟಿರುವಂಥ ಎರಡು ಡಿಫ್ರೆಂಟು ಬಲ್ಕಿ ಗ್ರೂಪ್ಸಲ್ಲಿ ಯಾವುದು ಜಾಸ್ತಿ ಬಲ್ಕಿ ಗ್ರೂಪ್ ಇರುತ್ತೋ ಅದು ಈಕ್ವಟೋರಿಯಲ್ ಪೊಸಿಷನಲ್ಲಿ ಎಲ್ಲಿ ಅಟ್ಯಾಚ್ ಆಗಿರುತ್ತೋ ಅದು ದಟ್ ಶುಡ್ ಬಿ ಮೋರ್ ಸ್ಟೇಬಲ್. ಓಕೆ, ಇಫ್ ಇನ್ ಕೇಸ್ ದೇ ಗೇವ್ ಎ different substituent group. This is all about the cis and trans isomer of 1,2 position. Okay, next we will move on to the third one, trans of 1,4 dimethyl cyclohexane okay. Here this is the structure 1 4 1 2 3 4 5 6 okay. Next the structure is here also the numbering is same at the 1 2 configuration, and here also 1 4 configuration also is same okay. Idu beda, here I am writing this is trans means 1,4 okay. EE or AA, this is EE okay. This is EE and this is A. This is the EE transformation and AA transformation. Here also in the above structure EE substitution is more stable than the AA because it has no 1,3 diaxial interaction okay. In this AA conformation there is no diaxial interaction, so that's why it is less stable. In the 1,2 position there will be diaxial interaction, so it is less stable. Here there will be no diaxial interaction in the 1,3 position, so that's why it is a less stable compared to EE. So EE is more stable than AA. ಗೊತ್ತಾಯ್ತಾ? ಇದು ಲೆಸ್ ಸ್ಟೇಬಲು, ಇದು ಮೋರ್ ಸ್ಟೇಬಲು. ಯಾಕೆ ಅಂತ. ನೆಕ್ಸ್ಟ್ ಫೋರ್ತ್ ಒನ್ ಈಸ್ ಸಿಸ್ 1,4 dimethyl cyclohexane okay. In that this is the structure and numbering is also same, that should be present in the trans okay. Here this will be the axial position and this will be the equatorial position. This is AE and another one is this is A, this is E position okay. This is EA position. Here AE is equal to EA because same substituent group is present at the different carbon atom okay. So that's why they have a same stable configuration okay, because there is no different substituent group is attached okay. This is all about the trans and cis 1,4 position. Next is 1,3 1,3 fifth one is cis 1,3 dimethyl cyclohexane okay. Cis 1,3 dimethyl cyclohexane. In that this is the 1 3 1 2 3 4 5 6. Okay, and cis means AA and EE configuration. Here you have to observe here 1. Okay, here the numbering is different from other two. Okay, here the numbering is starting from 1 1 2 3 4 5 6. Okay, 1 2 3 4 5 6. Here also you can take this number also. Here you can take 1 2 3 4. Okay, you can take also. Here this will be the axial position A. Okay, AA position, and this is EE position. Okay, E position. Okay, this will be also given like that. In this will like here and this will like here. Okay, it means 1 2 3 4 5 6. Okay, they will give, but you can use like this. This will be the E and this is EE position, and it is in the above structure. EE is more stable than the AA substitution. Same reason. Okay, because there is no presence of diaxial interaction. Okay, here there is no presence of diaxial interaction, and then again there will be presence of trans 1,3 dimethyl cyclohexane. Here in the position of A, that should be presence of AE. Okay, one is axial position and one is equatorial position, same as it is like this. Okay, but that should be present in third position like this. In the trans isomer, this will be the axial position and this will be the equatorial position. Okay, this is AE, or EA means one is should be present in this side or another is present in this side. This is the EA. Here both are same stability because same substituent group is attached. This is all about the conformations of cyclo 1, 2 disubstituted cyclohexane. Okay.